various renewable energy technologies to achieve carbon neutrality have emerged. Among them, solar power generation is the most used and accounts for 47.4% of total renewable energy generation at the present time in 2022. There is also a misconception that it harms the environment by the destruction of forests and farmland to install solar power generation facilities. As a result, the lack of solar power installation sites is becoming an obstacle to the spread of solar power generation. The Kia research team has taken a creative approach to this problem and is presenting a variety of technologies that can increase the adoption of solar power in cities, such as ultra-high-efficiency solar cell technology that maximizes power generation within a limited area, multifunctional solar cells that improve aesthetics, applicability, and acceptance regardless of the installation location, and a map technology that can accurately predict the solar energy resources of city buildings by using satellite images. Today, we invite the Korea Institute of Energy Research experts who participated in the development of this technology to help us learn more about this topic.
Urban photovoltaic power generation technology is a technology for urban spaces with a limited area without a large installation site. The key is to increase power generation efficiency by increasing the amount of power produced for a given area. The Kia research team has made this possible with perovskite silicon tandem solar cells. Let's find out more with Dr. Sejin An, who participated in this research and development. So these perovskite silicon tandem solar cells, how are they different from conventional solar cells?
The maximum efficiency of a conventional single-junction solar cell is about 30%. By experimenting with different ways to increase the efficiency of solar cells, we developed an ultra-high-efficiency solar cells by stacking solar cells with two different energy absorption bands to increase the utilization rate of sunlight. A perovskite solar cell is used on the top and the silicon solar cell is used on the bottom.
That is interesting. However, if the two solar cells are overlapped, then won't this create a problem with the light not being supplied to the lower solar cell?
Good point. Conventional perovskite solar cells are opaque because metal electrodes are used on the backside. However, we succeeded in developing high efficiency and high stability transparent perovskite solar cells by substituting a transparent electrode structure and increasing the light transmittance. As a result, we achieved the world's highest efficiency of 21.68% for light transmitting perovskite solar cells, and we utilized this technology for fabricating the tandem devices.
That is incredible. However, if you look closely, there is something peculiar. Is it a structure that can receive light from both sides? Could you please explain this?
Yes, that is correct. This is a double-sided structure. The tandem solar cell has a structure on which the lower solar cell uses the light remaining after being absorbed by the upper solar cells. The problem is that amount of light is too small. Our research team developed and applied bifacial technology that improved the photocurrent of the lower cell and achieved a dramatic performance improvement of 29.68% average efficiency at rear side albedo of 30%.
It is a very creative technology that utilizes even the reflected light off the ground surface without letting it escape. The research team not only developed a high-efficiency solar cell with an improved tandem structure, but also developed a new hole-transporting, self-assembled monolayer, also known as SAM, material. As a result of these efforts, their achievements have been recognized by publication in international journals. Urban solar power generators are installed on buildings rather than large plots. Therefore, customized solar cell technology suitable for complex building structures such as roofs, walls, and windows must be developed. Let's find out what technologies have been applied here with Dr. An Se-jin in the lab.
The research team divided the building into a roof, walls, and windows and developed customized solar cell technology for each part. This solar cell is the high-efficiency bifacial tandem solar cell described above. Since the roof is the location where you can get the most solar energy, the high-efficiency, high-stability bifacial tandem solar cells are suitable. Next are lightweight and flexible CIJ solar cells for wall applications and for industrial complex roofs. We have strengthened their flexibility and reduced their weight.
Flexibility and lightweight are essential characteristics, considering that walls increase the durability of a building and play a role in bearing loads.
Finally, we introduced solar panels installed on windows. What skills are required to install solar cells on windows?
Well, windows need sunlight to come in, right? So you must have a technology to make transparent solar panels, right?
Yes, that's right. The research team created a CIS-type absorber layer on a thin and flexible glass substrate to develop the world's first flexible bifacial light transmitting thin film solar cell device with excellent efficiency and performance characteristics.
It's amazing! Since solar power generation is affected by the weather and season, it is difficult to predict the power output. Therefore, in order to accurately predict the amount of solar radiation reaching the ground, it is necessary to calculate how much sunlight is blocked by clouds in the sky. The Kier research team developed a solar energy resource mapping technology for city buildings based on satellite imagery. Let's learn about it in more depth with Dr. Hyun-gu Kim.
If you look at a two-dimensional map of a city, it might seem like the sunlight will hit every building equally. But our cities are part of a three-dimensional world. Because buildings cast shadows, there are areas where sunlight does not reach and power generation efficiency decreases. The Kier research team developed the Kier Solar Map algorithm, which receives the real-time satellite images of Korean Peninsula from the meteorological satellite Cheolyan-2 at 10-minute intervals and precisely predicts the amount of solar insolation on the ground surface with a spatial resolution of 500 meters. In addition, the National Spatial Data Infrastructure Portal provided 3D building data across the country, the shadowing effect of building groups according to the sun's position, which changes every second for 365 days. As a result, we developed the world's first three-dimensional solar resource mapping algorithm that includes building rooftop, facade, and walls.
I see. How can we make the best use of this solar resource map?
Daejeon City is already using solar resource maps for BIPV. You only need to enter the building address or coordinates on the web page. Then you can easily check whether the environment is suitable for photovoltaic power generation, along with useful information such as monthly power production, electricity cost savings, and investment payback period. This technology has been expanded to artificial intelligence, so it can be applied to any city in the world, as long as there is a satellite imagery and building information. This is expected to greatly contribute to the expansion of urban solar power generation, which creates no environmental problems and allow the power to be consumed as soon as it is produced.
Photovoltaic power generation is an important technology for moving toward a sustainable society based on eco-friendly energy. In particular, urban solar power generation is a useful technology that maximizes the energy production efficiency in cities where many people live. KIR's urban photovoltaic power generation technology contribute to an eco-friendly, high-efficiency, predictable, and stable energy supply. And it is hoped that it will bring the world one step closer to the carbon-neutral society.
KIR is striving to further advance urban solar power generation technology and its spread around the world. Ultra-high efficiency solar cell technology, multifunctional solar cell technology, and solar energy resource mapping technology for city buildings based on satellite images are technologies that enable entire cities to be used as huge power plants. We hope that these technologies will accelerate the realization of a carbon-neutral society by contributing to an economical, eco-friendly, and stable solar power supply in many cities. We also hope that this technology will be utilized in more countries to help develop sustainable energy around the world.